Hello, welcome back to the channel. In the previous video, we already saw the conditional, that famous structure that says, if this happens, then that happens. Like when your mom tells you that if you clean your room, then she'll let you go to the party. But have you ever thought about what happens if we change the order of the words? Will your mom still promise you the same thing, or will this change? Well, today we're going to find out. And today we're going to talk about the three variants of the conditional: the converse, the inverse, and the contrapositive. Let's get started. Let's start with our original conditional. If P, then Q. And so that everyone is on the same page and we don't get confused, let's say the proposition is, if it rains, then the street gets wet. Everyone agrees with that, right? If it rains, then the street gets wet. This is a true proposition. In this case, the antecedent P is it rains, and the consequent Q is the street gets wet. Agreed. This proposition is true. Well, now let's play with it a little. The first variant we're going to look at is the converse. As you can see, we're basically switching the order of the antecedent and the consequent. Here, in the original condition, we had if P, then Q. And here we have if Q, then P. For this specific case, it would be, if the street gets wet, then it rains. Right. Let's write it down. Go ahead, analyze it a little. If the street gets wet, then it rains. Is this proposition necessarily true? Well, no. Right. Why not? Because the street could be wet because someone is watering, or because someone is washing their car, or simply because there's a water leak. So, the fact that the street is wet doesn't necessarily mean that it's raining. This means that this proposition is false. Easy, right? Let me move over here a bit so you can copy the example of our first variant of the conditional. Now let's go with the next variant. The next variant is the inverse. If not P, then not Q. Look, here we had in the original condition, if P, then Q. And in the inverse we have, if not P, then not Q. For this specific case, it would be, if it doesn't rain, then the street doesn't get wet. If it doesn't rain, then the street doesn't get wet. Let's write it down. Again, let's analyze the proposition using real-life reasoning. Look, if it doesn't rain, then the street doesn't get wet. Think about it. You go outside and see that it's not raining. Does this necessarily mean that the street isn't wet? No. The street could be wet for some other reason. Remember, it could be that, for example, there's a water leak. So the fact that you see it's not raining doesn't necessarily mean that the street isn't wet. Therefore, this proposition will be false. And that's how we get the second variant of the conditional. I'll move a little over here so you can write it down. And now let's go with the last variant, which is the contrapositive. Pay attention here because this one is a little more complex. In the contrapositive, we do two things. We flip the statement and also negate it. In this case, it would be, if not Q, then not P. Remember, before we had, if P, then Q. Here, we're flipping it. Notice that first we have Q and then we have P. And we're also negating, if not Q, then not P. For this specific case, it would be, if the street doesn't get wet, then it doesn't rain. Let's write it down. Let's see. Once again, let's analyze it step by step so we can determine if this proposition is true or false. It says, if the street doesn't get wet, then it doesn't rain. Let's see. Let's go out again and observe that the street is not wet. Does the fact that the street isn't wet necessarily mean that it's not raining? Well, yes, because if it were raining, then the street would be wet. In this case, then, the fact that the street isn't wet does imply that it's not raining. Therefore, this proposition will be true, right? Look, just to show you that I'm a nice guy, I've made a summary for you in this little table. I'll move a little over here so you can copy it, or just take a screenshot. Ready? Perfect. Well, let's continue. Look, it's important for you to remember that the original and the contrapositive have the same truth value, and that the converse and the inverse also have the same truth value as each other. Let's do another example, but a little bit faster this time. Here we have the original. If P, then Q. The proposition in this case will be, if a number is a multiple of 4, then it is even. Start thinking about whether this proposition is true or false. If a number is a multiple of 4, then it is even. That's correct, right? This proposition is true because, for example, 8 is a multiple of 4 and it is even. 16 is a multiple of 4 and it is even. 40 is a multiple of 4 and it is even. And so, all numbers that are multiples of 4 are even. Therefore, this proposition is true. Let's see what happens with the converse. Here we have, if Q, then P. Start thinking first about how it would look. Look, if Q, then P. In this case, it would be, if a number is even, then it is a multiple of 4. If a number is even, then it is a multiple of 4. This proposition will be either true or false. Careful, if a number is even, then it is a multiple of 4. This proposition is false because, for example, the number 6 is even, but it is not a multiple of 4. And here it says, if a number is even, then it is a multiple of 4. Therefore, since 6 does not satisfy it, it means that this proposition is false. So let's put an F here right away. Done. Let's continue. Let's go with the inverse. It says, if not P, then not Q. In this case, it would be, if a number is not a multiple of 4, then it is not even. Look, if a number is not a multiple of 4, then it is not even. Let's think about the truth value of this proposition. For this, let's take a number that is not a multiple of 4 again. For example, the number 10. The number 10 is not a multiple of 4, but is it even or not even? Yes, it is even. And here it says that if a number is not a multiple of 4, then it is not even. So this proposition is going to be false. And the example is 10 because 10 is not a multiple of 4, but it is even. Therefore, this proposition will also be false. Analyze it a little, because I know this might confuse you. If necessary, write down the proposition exactly as I'm telling you, so that you can verify that, in fact, this proposition is going to be false. And we finish with the contrapositive, which in this case is, if not Q, then not P. It would be, if a number is not even, then it is not a multiple of 4, right? It would be, if a number is not even, then it is not a multiple of 4. This proposition will be either true or false. Very well, in this case the proposition is true, because in fact, if a number is not even, pay attention, if it is not even, then it is not a multiple of 4. For example, 15 is not even. It is also not a multiple of 4. Or for example, 21 is not even, and it is also not a multiple of 4. So necessarily, if a number is not even, it will not be a multiple of 4. Therefore, this proposition will be true. And notice that what I told you before has just been confirmed. I told you that the original proposition and the contrapositive always have the same truth value. And on the other hand, we had agreed that the converse and the inverse also share the same truth value. Before you leave, I'm going to ask you to solve this exercise as homework. You have to do exactly what I did. You have to analyze its implication, its converse, its inverse, and its contrapositive. When you have the answer, put it down here in the comments. I'm going to give a nice big heart to the people who get it right. If you liked this video and it helped you with your homework or to study for your exam, please give me a like and also subscribe to the channel. Also, share this video with your friend who you know gets confused with logic. See you next time. Take care and behave yourself. Bye.